So it's been posed a question by Mike Green that a trail camera may emit some sort of electronic frequency, and as you can see, I have one of my stealth cams attached to one of my battery packs, and I'm going to use a device known as a K2 meter, which measures electromagnetic fields. Now, as we can see, I just want to make sure that the area is clear. Let's move this camera out of the way, and we're going to use our test area. Let's do a baseline reading of the area. And we have nothing. So let's put our... Sometimes if you jostle the device, it will give a false positive. We're going to put the trail camera over here. Okay, as you can see, it's on. It's already taken 5 pictures of me so far. But let's take this device and let's move it over the photo sensor, and there's nothing. But the interesting thing is that as we move it up into the LEDs, guess what? It's throwing off a lot of energy. A lot. Or it's redlining it. So in yesterday's video, we had determined that we know the camera itself, and as you see the camera, we have the passive infrared sensor, which was emitting no power surge at all, but the motherboard of the camera, right where the lens and the LEDs are, the IR LEDs are, does emit some EMF, or electromagnetic frequency. And the theory has been proposed that perhaps a Sasquatch can pick up or understand or sense this EMF. But my guess is a lot of people are naive in the fact that, there goes a state trooper, think that the EMF is emitted a great distance, when in actuality the EMF is most likely not. But we have the camera not powered on yet. As you can see down there, we got the battery pack. It's not powered up. We have a Keeson rod down here so we can measure distance, how far this EMF can actually travel out of this unit. So what we're going to start with is a baseline reading using the K2 meter. I have right here. It is powered on, and as you can see, the baseline reading, there's nothing on the motherboard because it's not powered up, nothing on the PIR sensor. As you can see, there's no EMF anywhere around here. Lovely day here in New York. So give it a second. We're going to power this camera on, and we'll be right back, and we'll give it the test. Okay, so now we've powered our camera on. As you can see, there's the trail camera. Taking some pictures. We're ready. Still in test mode. That may have been from when I set it up earlier and made sure everything was working. We're all set to go. The cable's up. It's powered on. So this should light up like we did last time, and there it is, like we saw in yesterday's experiment. So I'm going to back it up a little bit, and as you can see, the minute I step back, that frequency is gone. It's not there. Even on the side of the unit, it's not there. On the back of the unit, we have a little bit. So we know it has something to do with the motherboard on top of the unit. No, but it's to the sides. We have a little bit of EMF. But right here, we definitely have EMF. But literally, we take it off maybe a couple inches off, or even an inch off, and that frequency is gone. So for the most part, that frequency is contained in a unit. So I don't think it's going to be very easily sensed by any type of creature whatsoever. Again, does it make an ultrasonic sound? I don't know. I may have to get a device that can pick up frequencies that we can't hear. But as far as I can see, the EMF frequency, if you move it right to here, it's not there anymore. So, and as you can see, it's not even, our tape has moved a little bit. I mean, it's maybe an inch, 2 inches at most before that EMF frequency dissipates and is no longer present. So obviously, again, to me, the reason why we don't get pictures of these things because this is just a needle in a haystack, limited field of vision. You got to be lucky enough for the sensor to trip. Got to be lucky enough for it to be in the range of the camera after the sensor trips and it signals to the camera. So anyway, catch you in a bit.